Welcome to All This Math. This is Professor Parker, back at it again. Today we're going to do some work with inscribed angles. And actually, this problem actually is for, or this example I should say, is dedicated to the students some students over at Simon Grass High School over by Nicetown in Philly. And my man Coop, this is for some of his geometry students. All right. I mean, it's for everybody, but specifically for y'all. So shout out to y'all for learning geometry, right? Don't believe people when they say black people don't do math. Don't believe that. We've been doing math. All right, now, inscribed angles. Now, first off, what is an inscribed angle? What is it? An inscribed angle is an angle inside of a circle, right? So here we got a circle, right? An inscribed angle is an angle that has a vertex on the circle, right? So the vertex. So the vertex of an angle, or the point where the two rays that come together, right? Like this angle right here. Well, let me talk about this one because we know the value of this angle. This is a 55-degree angle. This ray or this line segment right here connects with this line segment, right, to form a 55-degree angle. That angle vertex is on the actual circle right there. It's right there on it, right? So this would be called an inscribed angle. Same thing with this angle. This is also an inscribed angle. Now, there's some things we know about inscribed angles. All right. So there's some theories that, your teacher's going to show you, right? And you're going to probably copy down into your notes and try to memorize as soon as possible. All right. One of the things we know about inscribed angles is this. You see where the angle is right here, and then you see that the ray or the segment extends out like this, and this segment extends out like this. This space on the circle from this endpoint to this endpoint is called an arc. It's called an arc. That's an important term, an arc. So I'm going to write that down, an arc. An arc is basically a piece of a circle, right? That's what an arc is. An arc is a piece of a circle. Think about it like when you buy a whole pizza, the pizza crust is the arc, all right? That's the pizza crust. Some of y'all might not eat pizza crust. Some people throw it away, whatever. But the arc, you can think of pizza crust on a pizza. That's an arc. So now the question we should be asking is, how does this inscribed angle relate to this arc? Because don't it look like this arc is like in between or like inside the inscribed angle, right? It do, right? So like this angle is right here, and then this arc is right here, from here to here, right? So we got an angle and we got an arc. We got an arc and we got an angle. Now, when you're dealing with circles and you have an inscribed angle, the arc most textbooks say that it intercepts or that it intercepts or subtends, right? They have a special relationship. The measure of the angle is always, now you want to write this down. You're going to want to write this down. The measure of the angle is always half of the measure of the arc. And we also measure arcs in degrees too, right? Remember, the arc is like pizza crust. All right? The arc is pizza crust. The whole circle is a whole pizza, right? The measure of the angle, so if this angle is 55, then what does that tell us about this arc? This arc has a measure of 55 times 2 because the arc is always double the angle. So I can set up an equation. Right? I could say y equals 55 degrees times 2. So then I would say y equals 110 degrees. So that's one of my answers. And I'm trying to find the missing values. So I didn't know what y was. Now I do. I don't know what x is, and I don't know what z is. Right? So again, that's a rule that you're going to have to remember. Right? The inscribed angle, the measure of the inscribed angle is always half of the arc that it subtends. Subtends. What does subtend mean? Subtend means that it the rays or the segments that create the angle, right? When they extend out, they basically create the arc, right? It's kind of like if you sliced, like if this was a pizza if somebody made like a weird slice and they ain't slice it from the center, but instead they sliced it from the edge, the other side of the pizza, and they could put the knife and went just like that, and it went just like that, the crust that you created is the arc, right? That's related to the angle of the pointy part of the pizza. All right? So that's one way to think about it. And as you do more and more of these problems, you'll think of other ways that make more sense to you. But just know that there's a relationship between an inscribed angle and the arc that it creates, basically. Because basically the inscribed angle creates the arc. So the length from where I drew in blue, this point right here, to this point, that's the arc. Now the arc is always double the measure of the angle. Double the measure of the angle. The arc is double the measure of the angle. You need to memorize that. All right. Now, conversely, the angle is always half the measure of the arc. All right. So now let's look at how we're going to figure out what x is. X is the inscribed angle. So now we don't know the inscribed angle, but we know the arc that it creates. This angle creates this arc from here to here, from here to here, or here to here, and that's 80 degrees. So the inscribed angle is going to be half of the measure of the arc. So I could do this. I could say, all right, well, if that's the case, then I know that x is going to be 1/2 times 80. 1/2 times 80. Now, if x is 1/2 times 80, I know a half of 80. Like if I'm, trying to buy some sneaks that cost $80 and they half off because there's some type of sale going on, I know I'm only paying $40 for the sneaks. So 1/2 times 80 is going to be 40. So that means that this is 40 degrees. So now I know what y is. Y was 110. Now I know what x is. X was 40. Now, last thing I need to figure out is z. Now, z is an arc. But when I look at z, I say, okay, well, what inscribed angle created z? And I don't see one. I don't see an inscribed angle that created z. I see an inscribed angle that created y. I see an inscribed angle that created this 80-degree arc, right? But I don't see an inscribed angle that created z. So now I got to think about what else do I know about circles? And one thing I know about circles is that the total angle measurement of any circle is 360. The total angle measurement of any circle is 360. So like, for example, if I started at this point right here and I went all the way around and I came back to the point that I started at, that would be 360 degrees. So that's why when somebody say they made a complete 360 and they want you to think that they changed, they actually ain't changed. They back right where they started at. What they mean to say is I did a 180. When you do a 180, it's like you started at one point and you end up at another point, right? So you change something about yourself, all right? If you did a 360, that means you right back where you started, right? Now, if I know all the measurements of all the arcs or all the pizza crust around here except for this piece right here, I can figure out what this piece is. I can create an equation. Remember, geometry, at some point it really stops being geometry. Really, we're doing algebra 1 after we deal with the shapes and after we deal with all the rules that apply to the shapes. So what I'm going to do is this. I'm going to look at all the arcs, right? Because I got 1, 2, 3, 4 arcs. 4 arcs are making up this whole circle, right? 4 arcs are making up the whole circle. So I got one arc up here, that's 90. So that's going to be part of my equation. I got another arc right here, that's 80. That's part of my equation. I got another arc right here, that's z. That's part of the equation. And I got another arc right here, which is y. That's part of the equation. Now, all 4 of these arcs, 1, 2, 3, 4. See? 1, 2, 3, 4. All 4 of those arcs put together, you can visualize it. They make up the entire circle. That's what they do. They make up and compensate for the entire circle. So all 4 of them arcs got to add up to 360. All right? Now, this is a little, hold up. Let me fix this. I don't want everything to be all crowded on this board. I don't want nobody to be confused later. All right? So really, I want this, right? So now I want to simplify this, right? But actually, before I even simplify it, I don't need to use y because I know what y is. We only use variables to represent values that we don't know. But because I know what y is, I don't need Y. I don't need to use the letter Y. I just use 110. So now I'm going to rewrite it. But wait, before I rewrite it, I'm going to combine these like terms. This 90 and this 80. I'm going to add this 90 and this 80 together. That's going to give me 170. I'm going to save some time. So I'm going to do 170 plus Z plus 110 equals 360. So I got 170 plus Z plus 110 equals 360. Right? So now I still want to combine like terms because, again, this is algebra. I'm trying to solve for Z. So I do 170 plus 110. That's going to give me 280. So now I got 280 plus Z is equal to 360. So I got 280 plus Z is equal to 360. So now I'm going to just do some multiplication. I'm going to isolate Z by itself. I'm going to subtract 280 on the left. I'm going to subtract 280 on the right. Now I got Z equals, and 360 minus 280 is 80 degrees. And that's this arc right here. And if we want to check our work, we just make sure that 90 plus 80, 170, 170 plus 80, 250, 250 plus Y, which was 110, is 250 plus 110 equal to 360? Yes, it is. So these are our three values. Y equals 110, X equals 40, Z equals 80. So we used a couple of theories from circle geometry. One theory is that the total angle measurement of any circle, or all the arcs on any circle, is 360 degrees, right? That's one of the theories we used, okay? One of the rules. Also, the inscribed angle rule, which is the measure of any inscribed angle is equal to half the measure of the arc that it creates. And when I say it creates, think about it like this. This is the angle right here. This angle has this segment right here going like this, and this segment going like this, right? The space on the circle in between the endpoints of these two segments creates an arc. This basically curved segment from this point right here to this point right here, that's an arc. That was created by this angle. All right. Some textbooks use the word or the term subtend or intercept. I like to think of it as, the angle created the arc. For real, it created it, right? Because the segments that create the angle extend out like this and like that. And then you got the arc in between the two joints. Sorry, you know what I'm saying? So, boom. So the inscribed angle is always gonna be half of the measure of the arc. Likewise, the arc itself is always gonna be seen as, it's gonna be double the measure of the inscribed angle. So those are some things you gotta remember. Those are some things we used to answer this question, find the missing values, and now we're done. And that's just a little bit of intro to inscribed angles and just some circle geometry. All right, please, a like, and always remember, a like and a subscribe will support me a lot. I appreciate it. Tell some people about this video. Send it to some people. Just send it through your phone, whatever. Ain't no big thing. All right, and always remember, there's all this math all around you. Peace.